Welcome back to Circles Unit 9, Day 4 notes. So, the last video ended, I was wrapping this up. So 2x equals 35, divide both sides by 2, x equals 17.5. That's your length from A to E. All right, let's check out some more. All right, next problem says lines AE and lines BD are tangent to circle O and P at A and E and B and D, as shown in the diagram below. Okay, so then it says if the ratio from A to C to C to E is 5 to 3, and the length from B to D is 56, we have to determine and state the length of line segment CD. So this one's a little bit more challenging. All right, so from B all the way to D, we have to indicate that that is 56. And these are ratios. So we're going to represent AC as 5x and CE as 3x, because ratios are numbers that have been reduced. So AC, I'm representing that by 5x, and CE, going to represent that by 3x. All right, so it turns out that we can use the part times part equals part times part. It turns out that these two tangents end up actually being equal to each other. If we have two tangents drawn, because it turns out this section is going to be congruent to that section. This section is going to be congruent to that. So remember, two tangents drawn to a circle from the same external point are congruent. And then we have two tangents drawn this way are congruent. So it turns out by segment addition that 5x plus 3x is going to equal that 56. So altogether you get 8x equals 56, divide both by 8, x equals 7. So we can now substitute that back in. The length from C to E was 3x, so 3 times 7 is 221. And it wants the length from C to D, so CD is going to be that same length, 21. So that one's a little bit different. All right, so that's just some examples of finding lengths of segments. All right, let's check out number 4. In circle F, secants ABC and secant CDE are drawn from external point C such that points A, B, D, and E are on circle F. We have to prove the length from A to C times the length from C to B is equal to the length from E to C times the length from C to D. So again, when you have a product of lengths equals a product of lengths, that must have come from a proportion. So if we start to set this up as a proportion, AC in the top left, when you cross multiply, CB has to be in the bottom right. And then the other two go on the other diagonals. So if you look at this, AC, EC, and CD, CB. So we could say that there are two similar triangles here. So the way to do this one, to prove this, is we are going to connect line segment BE, lost my pencil. We're going to connect, we're going to crisscross connect, and we're going to connect the line segment AD. This now creates two similar triangles. So we can now prove triangle ACD is similar to triangle ECB. So remember to try to match up correspondence. All right, so first thing we're going to do is prove triangles are similar, then we can do the proportion, then we can do this cross product. So I'm going to start with my statement reason proof. And the only way to get triangles similar, we don't have any measurements, we need to do angle, angle. So first I am going to kind of list all this given. So we have circle F, I have secants ABC and CDE are drawn from external point C such that points A, B, D, and E are on circle F. So that was all my given. All right, next thing we do is we were going to draw on those segments. So draw line segment AD and line segment BE. So same reason we used before. Through any 2 points, there exists one line. That's perfectly legal to do that. Okay. Now, did you notice in each of these two similar triangles, they overlap, but they both have angle C in it. So angle C from one triangle is congruent to angle C from another. And that is our good old friend, reflexive property. So there's our one angle in each. Okay, next easiest thing to do is to get angle A congruent to angle E. Do you see why? Angle A is an inscribed angle, it goes to arc BD. Angle E is an inscribed angle, it goes to the same arc. So we're going to use that same theorem we used in the other proof. If two inscribed angles intersect the same arc, they are congruent. There's our second angle pair. So now the rest is the exact same as before. Triangle ACD is similar to triangle ECB because of angle-angle similarity. Then you can write your proportion. So if similar triangles, then corresponding sides are proportional. Okay, and then lastly, our cross product AC times CB equals EC times CD. Same reason as before. If proportion, then the product of the means equals the product of the extremes. Oops, running off the page. So there you have it. So on the next page, we could write this theorem, of course, using some silly thing to help us remember it. So there's a shortcut. All right, so this actually kind of splits up the notes. 4 now leads with this information here. All right, so what you just proved was the length of this whole segment. So if we take this secant and we broke it up into length X and length W, if you take the length of the whole thing by adding it and multiply it by the length of the segment that's outside the circle, it equals the same on the other secant. The whole times the outside. Whole times outside equals whole times outside. It works if you just have a tangent and a secant. So again, the whole segment times the measurement on the outside equals the whole segment, which just is the tangent, times the length that's on the outside, which is also the tangent. So I like to call this woo-woo. Get it? Whole times outside equals whole times outside. Woo-woo. And just like PP, it's fun to say woo-woo. PP and woo-woo. Part times part equals part times part, or whole times outside equals whole times outside. So again, you could memorize this formula and recognize when to use it, or you could draw in line segments and create similar triangles and set up your proportion. All right, so let's check this one out. In circle O, I don't have a circle O, so let's draw a picture. Oh, that's beautiful. Circle O. Secant ABD and AEC are drawn from an external point A. So a secant, you need to know, touches the circle twice. We have something like this going on. A is my external point, and I can call this one D and that point B, and then A, E, C. All right, such that points D, B, E, and C are all on circle O. If the length from A to D is 8, and the length from A to E is 6, and the length from E to C is 12, oh, it's 12 more than the length from B to D, so I need to assign that to be X, and then this piece is going to be X plus 12. Find the length of line segment BD, so we just have to solve for X. So, again, I want to reinforce similar triangles. So in this situation, if I connect here, I can prove angle A is congruent to itself. Angle B and angle C are both inscribed from the same arc, so they are similar, or they're congruent. So I can prove triangle ABE is similar to triangle ACD by angle-angle similarity. You have reflexive, and two inscribed angles to the same arc are congruent. So then from this, I can set up a proportion. I can go from A to B over first two letters AC. And then I need AE is first and second. AE has to match up with AD. So let's put these in. I need the length from A all the way to B. So I'm going to have to add those two pieces together. Over AC. To find AC, I'm actually taking X plus 12 and adding the 6. And that's going to equal my length from A to E, which is 6, over my length from A to D, which is 8. So these need to be in parentheses. So if we cross multiply now, we're going to have 8 times 8 plus X equals 6 times X plus 12 plus 6. So right there is my woo-woo. I have my whole length times the outside piece equals the whole length times the outside piece. You could have started the problem here, but again, I'm trying to reinforce all the similar triangle stuff. All right, let's distribute in 64 plus 8x. First, I'm actually going to combine these. That's 18. Oops, I forgot my x. I'm trying to hurry because my video time's almost up. 18 times 6. I don't know what that is. Could figure it out, but I'm in a hurry. 108. All right, let's get our x's on the same side of the equal sign. Oops, that doesn't cross out. You get a 2x. Let's subtract 64 from both sides. 108 minus 64 is 44. 2 times x is 44. Divide both sides by 2. X is 22. It wanted the length from B to D, which is x. And that's one of the multiple choice answers. So that question was on a Regents exam one year. A lot of students struggled because they didn't even know what a secant was, so they couldn't draw the picture. And they couldn't even start the problem. All right, so there you have it. PP woo-woo. Enjoy doing day 4 homework. Bye!